All right, hello everyone. We're the team from the Georgia Institute of Technology, and we will now be presenting our result on the question, to what extent are countries' green transition goals, as set out in their strategies, reflected in their STI policies? Next slide. So we will structure our presentation first, giving an introduction with the climate change, the background of climate change and the Paris agreements, to give the justification of why countries need to pursue rigorous climate goals. We then will go into our methodology using neural network classification and topic model, as well as clustering to try to interpret all of the text documents, and then later present some of our results and conclusions.
I'm sorry to interrupt you. It seems that there are some problems with your microphone. Maybe could you try using your laptop microphone? If you have another one?
I am using my. Can you hear me? Hello.
Yes. I think let's give it another try, but there was some interference in the microphone.
Okay. But, hello.
Give it another try.
Okay. Can you hear me now? Is it okay now?
Yes, it's working now. Yeah.
Okay. So for our presentation, many countries are focusing rigorously on climate policies due to the urgency of climate change. According to the most recent IPCC report, there will be devastating consequences for the planet if we reach 1.5 degrees of warming by 2040 above pre-industrial levels. Therefore, the Paris climate goals, which are set in 2015, are put in place in order to limit our global warming by below that amount. And countries pledge ambitious climate action in order to achieve that goal. Nevertheless, how are countries translating their ambitions into policies? This is one of the questions that we'll be asking, and that will be motivating our hackathon question.
Yeah, so if Daniel, you can move to the next slide. Yeah, so what we had to do next was to classify our texts into whether they belong to green transition, check the semantics of green transition or not, right? And so we had about 300 documents, and we had to turn them into sentences because that's the way neural network classifiers work. And that's what we did. We created a script and did that. And that was not an easy task, by the way, but it probably does not belong to this presentation. But what does belong to the presentation is the way we created the ground truth data set, which was only 800 observations. So it was relatively fast for us to kind of create it. But we had to feed this ground truth data set with examples where, for instance, where such as climate change or sustainability are used both in the context of green transition and the context of non-green transition, because the way a neural network classifier works and is trained is to handle those non-linearities, and that kind of brings us to our next slide, which so kind of describes what the BERT neural network classifier does, right? So BERT, and we have so in our team we kind of have published quite extensively on BERT with BERT, and so we kind of had that expertise in house. But so really, BERT is really great at handling non-linear classifications where it is very ambiguous whether presence of words such as sustainable or transition makes of a sentence a green transition related sentence. And the reason why BERT is good at doing that is because it's trained in a bidirectional way. And this leads us to our next slide, where we kind of show this graph shows the way BERT operates, and really I would like to point your attention to kind of the bottom of the graph where we show the tokenization that BERT does. So BERT, the way BERT is pre-trained is by tokenizing sentences, so that each word is assigned with a token, and then specific given words are masked at any point in time, and they are being predicted by the text that comes before and the text that comes after, so that BERT can really handle those ambiguous texts where such a sustainability is being masked, but the neighboring words are the ones that are being used, right, to classify this sentence. So really, we thought that the BERT architecture lent itself quite nicely to our task. And this brings us to our final slide on BERT, where we show what the output is, right? So for each one sentence that we add, we got one prediction, which was of course a 0 or 1, 1 when the text was classified as an environment-related, green transition-related sentence, right? And we want to actually point out that it only took us less than 1 minute to train the model and only about 21 minutes to predict the 380,000 sentences. This shows how these deep learning algorithms can really leverage economies of scale with prediction. And the final step we had to do was to kind of smoothen out the prediction, so that when there's a lot of density in terms of ones, so that a text which is a 0 is surrounded by a lot of ones, we really want that to be a 1, right? Because you can definitely juxtapose one non-environment related sentence with a lot of environment related sentences, and we wanted to smoothen that out so that we can really pull out the texts that belong to the green transition topic. And that's what we did, and what the two graphs at the bottom of the slide show, right? The smoothened sentences really extract only the text which is relevant. And we shall move on to the next slide. Daniel?
Okay, sorry, can you hear me now? Yes.
Yes.
Okay, sorry about that. I was muted in the Teams. So one of the goals that we have essentially is to be able to determine from the strategy data set what are the main green transition goals that are posed, and then map that onto the Compass data set. This is very similar to what the last group did. So in order to get the initial goals, we move into topic modeling. So for people that don't really know what topic modeling is, there's this idea where when we have a corpus of text, can we create a latent space that is used to explain how the text is generated? Classical techniques like LDA or non-negative matrix factorization essentially assume that this is like a random process, usually Dirichlet, that approximates word topic spaces latently. But newer techniques such as topic debec or per topic instead look at this in a different way, where they're essentially asking what exactly is a latent topic. And the general idea is, if you look at a latent topic as being relative semantic similarities between documents in a space, you can essentially use clustering techniques on those spaces to find the latent topics, essentially. So this is the general architecture for a BERT topic. You essentially take a set of documents and you put it through the model, and it will spit out the documents with an assigned topic to it. And within the actual topic model, there's 3 main stages. The first stage is you use an embedding model. In our case, we use Microsoft's MPNet to generate embeddings. And the embedding model just creates a vector of numbers for every sentence. However, those vectors are relatively large, and clustering does not work well on large or high dimensional vectors. As you know, MPNet has approximately 760 numbers per sentence. So we use UMAP, which is uniform manifold approximation and projection, to reduce the dimensions. And how that essentially works is a nonlinear method that uses nearest neighbor methods to take a high dimensional graph, and it compares the weighted similarity scores between the nearest neighbors of a given point in the high dimensional space to a low dimensional representation, and it changes a low dimensional representation to minimize a cost function. And then with that reduced matrix, we can use clustering. HDB scan is the clustering algorithm that's used right now, which stands for hierarchical density-based spatial clustering with applications and noise. Essentially how that works is it's similar. It uses nearest neighbors to construct smooth probability spaces where it tries to find dense probability regions, and it will determine if there's like two dense regions near each other, if that's actually one region or not. The details into that are a bit complicated, but it's generally how it works. So for us, we had this huge issue where the strategy documents were too clean at the one stage where we were just given tokens, but when we had the full translated text, they were incredibly messy, and splitting them into sentences gave us very noisy data, which topic models don't really work well with. So to help with that, we additionally removed punctuation, words with less than 2 characters, increased our classification threshold. So we made sure that everything that was being put into the model was actually related to green transition. And we also excluded short sentences, as they generally don't have a lot of information, which gave us a final N of approximately 13,200. We tuned the parameters to get from an initial 700 topics down to 70 topic clusters, with 46 of them clearly relating to green energy or green transition. And just as an example of the output, the -1 topic is considered noise. So HDB scan has this good property where if data point is too noisy or not close enough to a cluster, it's considered an outlier and is discarded.
Dario,
and then,
so sorry, apologies to interrupt. I mean, this is really fascinating to me, and I feel very bad to interrupt you. It's just that we are a bit short on time. And as we were saying, we will cover again some of the details in a follow-up meeting. But if I could ask you to, yeah, I see that you still have a lot to cover in your slides, and your 10 minutes have already passed. If you could, yeah, in a couple of minutes, present that would be great.
Sure. So essentially, with the results, we picked out the ones that were clearly related to green transition, and we then used that to really answer our question.
So the topics that Dan just presented were really, we have like 40 or so sort of topics, but a lot of them could be classified into more narrow topics. For example, we had topics related to renewable energy, hydroelectricity, nuclear, etc. And so we consolidated those topics into a single alternative energy topic, as you can see in this graph. So after we went through each of the topics and read some sample sentences in order to fuse them into much more sort of broad topics and map their distribution across all of the countries. And this is the distribution. Without going into further detail, you can see that there is considerable variation as to how many sentences like each of the countries have in total, as well as their distributions relating to which fields that they focus on. Next slide.
So then, based on the results in the topic model we just showed before, we generated 2 indicators to measure countries' commitment to their green transition goals. One is what we call green intensity ratio, GIR, the percent of green sentences in each country's STI documents. It represents like how aggressively countries describe their green transition goals. Another one we created is called green broadness ratio, GBR. We calculate that as a percent of green topics out of all possible green related topics that have been covered in their STI documents, indicating like how broad their green transition goals are represented in the text. So next slide. Here we visualize like where OECD countries are in terms of GIR and GBR. We can see the positive association between the depth and the breadth of green transition goals. It turns out the OECD countries can be divided into 4 groups. Like the purple group on the top right has broad green transition groups, which are intensively described, while the green group like has both low GIR and GBR. So next slide.
So to really get at the question, we wanted to see, going from the strategy to the compass, like how this intensity and broadness actually tracks. So essentially we use the same metrics as before, but we for the x-axis it'll be the strategy data, for the y-axis is the compass data. And you can see for the intensity ratio, there's still a general positive trend. So if you're intense in your strategy, you're also likely to be intense when describing green transition in your compass. However, if we go to like broadness, there's a less of a positive correlation, especially if you exclude the United States, as that's a fairly extreme outlier. However, this is not a conditional correlation, because this is saying in the strategy, like how many of the, like what percentage of the 40 some topics are you describing, and then same with the compass. If we instead condition it so that we only count for, let's say a country describes 20 topics in the strategy data, if we only are counting those same 20 topics in the compass data, does the general positive trend hold? And the answer to that is no. If we are only looking at the conditional strategies that a country uses, there's actually a general negative trend, especially if you don't include the United States. So it does not really look like that there's a actual transfer of like strategy into initiative, from what we can tell. And I think in interest of time, we probably don't really need to summarize everything. But if you have questions, we can go into more detail.
Thank you very much. Yeah, sorry again for rushing you, but I think you managed to cover the material very well. So yeah, I mean, those 2 measures that you have proposed are really interesting to ways of summarizing the data that I haven't seen before. Now let's give the floor to Jan, who will comment on Caroline's absence.
Yes, Caroline, she can't make it to this meeting. That's why I'm taking over. But first, thanks to the group. I think this is very impressive, and you used highly sophisticated methods that I could never use. So I think we definitely need a follow-up meeting to this. So my first remark is related to or goes back to the question, because that's about green transition goals. But when I look at the topics and also your indicators, I think it's still an open question whether they actually measure goals, and also whether higher salience or higher values in this indicator equal more importance of these goals. So I'm not quite sure to this, and that makes it, of course, difficult to then to compare both data sets. And then the second remark is related to the country ranking, and then you also talk on your last slide about countries' commitment to the green transition. But then actually the green transition is quite a broad concept, and then it's highly sensitive to say some countries are more committed than others in this very broad concept. So maybe further analysis could break this down and maybe to look into groups of topics, and also in your classification, maybe you could go on a lower level And yeah, I think there are some pre-trained classifiers of the SDG goals, for example, and then you could have maybe a more fine-grained analysis of countries' commitment.
Yeah.
And then the
so
third
to
point, sorry.
Oh no, go ahead. Sorry.
And the third point is something we also heard in earlier presentations, and that's related to the validity or the stability of the results. I think there's always some randomness involved in these machine learning applications. So I would be curious to hear how stable your results are, also because you used a relatively small training set, as I understand it. So yeah, I think that's something to discuss. And then yeah, I would be interested to hear about your potential next steps. So one thing that would be interesting is maybe a multilingual classifier, because yeah, translating these documents always induces some errors, and that's also quite time consuming. And then also, did you try any methods maybe that failed, or did you at all try any other methods that maybe gave you different or less reliable results? And that's it. But I think in general, that's very impressive, and thanks a lot.
So just to address a couple of the points, we thought about creating a multi-label classifier to really get at, because one thing with topic modeling is it's not as stable as classification, because with classification you're typically manually reviewing everything that's being put into the model and verifying it yourself. In this case, we're essentially relying on correlations, relatively complex correlations, but correlations nonetheless between words. So that's would probably be better in the long run. However, multi-label classifiers, at least when I've written papers on them, take like weeks worth of man hour. We've had like 5 people spend like 40 hours each just to get a data set to label like 8 topics or 8 categories. So for the scope of the hackathon, it didn't seem worth our time to invest in that to get poor results. But it's definitely something to consider in the future. As to the goal thing, we did make a simplifying assumption that everything in the strategy data set is a goal and everything in the compass is a policy. We could potentially build a classifier to parse that apart better. I don't really trust keyword parsing because I think that has a chance of missing out on semantically similar words that you aren't thinking of at the time. So that would be a future direction. Would also be to make sure that every sentence that is included is actual goal, or to at least use the topic model to as a starting off point for an actual typology, which could bypass the need of having to classify goals as well. That's another possibility. Those are our general thoughts, I would say.